Hello friends, how are you doing? In this video we are going to learn how can we apply strain to our material. So we have to first create a directory for our strain, and we also have to create another directory which is for unstrain. So you have to copy your unstrained calculation in the unstrained data, and so that both won't mix. So in strain basically we have two type of strain. One is called hydrostatic strain and the other is called biaxial strain. And I'm gonna tell you in a moment what is the difference between hydrostatic strain and biaxial strain. And in hydrostatic strain and as well as in biaxial strain, there are two types of strain. One is called tensile strain and the other is called compressive strain. So we're gonna create the directories for them, and here we have the directory for compressive strain, and we're gonna copy those two directories and paste them in biaxial as well. Right, I'm getting an error. So it's tensile and it's compressive. So now you have to look for your structure file that you created in the WIEN2k web terminal, sorry, web page. And here we have the structure file. So we have to copy that and paste it outside both the directories, so you have that for comparison. So I'm gonna apply up to 3% strain, both tensile, both tensile and compressive, and for hydrostatic as well as for biaxial. So I have to create AO1, which indicates my 1% strain, and AO2 for 2%, and AO3 for 3%. Similarly, in the compressive, AO1, AO2, and AO3 for 1%, for 2%, and for 3%. Similarly for biaxial. So I'm gonna copy this structure and paste this structure in every directory. Basically in strain we play with the atomic the lattice parameters. We increase them or decrease them, so it tunes the band gap and changes the properties of material as a whole, and have remarkable effects on the material in some cases. Like for my material, I use strain study to optimize its band gap for solar cell applications. So these strain studies are very useful in many applications. So let's apply the tensile strain first. So here you have a structure file. No, I'm not gonna save it. Yes, this is my structure file, and these are the lattice parameter along x-axis, along y-axis, and along the z-axis. So in hydrostatic strain, you apply strain on along x, or you apply strain on A, and you apply strain on B, and you apply strain on C. For cubic, all of these threes are identical, so the amount of strain on this system is the same, and it will not gonna affect its symmetry, like 1% strain in this, 1% strain in this, and 1% strain in this, all these three lattice parameter. But in case of biaxial strain, we apply strain on the lattice parameter, only two lattice parameter, along A, on Y, on sorry, A, and on B. So these are my lattice parameter in Bohr, so I have to copy them and add 1% strain to them. So we have to use calculator for that. So I'm gonna just plus 1%. So it increases my lattice parameter by 1%. So these are the updated lattice parameter. So you have to copy after the decimal up to 6 digits. So copy this and paste it right here, and similarly paste it right here, and paste it right here. And now you have successfully applied 1% strain to your compound. And now you have to perform the similar initialization process, the same initialization process, and the same SCF calculations that you have learned previously. So now I'm gonna apply tensile strain of 2% on this compound as well. So I have to copy this unstrained lattice parameter and put this thing in my calculator and add 2%. So the updated lattice parameters are 52, 512, 299. So I'm gonna copy it as it is and paste it right here. So keep in mind it's hydrostatic strain, so I'm applying on all ABC, on all ABC. There you go. Now you have the 2% strain. And also keep in mind you have to rename your structure file or your files according to the directory you're working on. So my directory is AO2 but my structure is AO1, and this can cause a very common error in a DFT that beginners face. So I'm gonna rename it to AO3, and now you can apply tensile strain of 3% in this. But for the compressive strain, you have to open your structure and minus 1%. Minus 1%. So when I minus 1% from it, the updated lattice parameters becomes 938407. So you can have an intuition how these lattice parameter increases or decreases with the strain. So right now I'm performing hydrostatic strain, so I'm gonna paste it on all the lattice parameters A, B, C. So now I'm gonna apply biaxial strain to some of the compounds. AO1, Control Shift AO2, Control Shift and AO3, and just copy the structure, the unstrained structure, because you are applying strain on the unstrained structure. And never misuse the wrong structure file, like do not apply 2% strain on already applied 1% strain. Always use the unstrained structure to apply strain. So I was working on this, yeah, and I'm gonna just open it. Yes. So it's basically the tensile strain, so the similar process as the hydrostatic strain, but in this case we're gonna apply strain to A and B only. So I'm gonna copy it and paste it here and add 1% to it. So the updated are 321002. But in case of biaxial strain, the symmetry changes for my material from cubic to a monoclinic structure, because you know in monoclinic A and B are the same and C is different, but all the angles are at 90 degree. So these are some you know, the geometry of the compounds. So this is how you can apply strain in your strain or your compound. So let's just overview it. So you have to first create a strain directory, and you have to make two separate directories like hydrostatics, one for hydrostatic, one for biaxial. And in hydrostatic there is always tensile strain, which adds some value to the lattice parameter, lattice coefficient, and for compressive strain it it reduces the lattice coefficients. And in biaxial strain, same process for tensile and compressive, but in case of biaxial we apply strain only on A and B two lattice coefficient, so that the for cubic structure it usually turns the cubic into a monoclinic structure. So when we apply strain on the compound, as I mentioned previously, it increases the band gap or reduces the band gap and make it fine. Like we call it band gap tuning through strain studies. So I hope this video will be enough for you for how to apply strain. And if you have any question, you can just ask me in the comment section, or you can follow me on Instagram and DM me there. Uh, so I think this is enough for this video. See you in the next video. Till then, take care. Peace.